Okay, so this is solutions review. Make sure you have your reference tables and a calculator ready to go. Number one, a dilute aqueous potassium nitrate solution is. First of all, solution is something solute dissolved in a solvent, which is two separate things, so it cannot be a compound. So then if it is a solution, that means it's all the way through uniform, so it would be homogeneous. A mixture of crystals of salt and sugar are added to water and stirred until all the solids are dissolved. Which statement best describes the resulting mixture? So, would you be able to see salt and sugar crystals in the water once you dissolve them? No, which means it would be homogeneous. Then you say, could you separate it out? Could you get just the salt and then just the sugar by filtering it? Well, no, because those things, since they are dissolved, are so small, the particles would not be able to be separated by filtration. So, choice 2. An example of a heterogeneous mixture, which is one in which you can see the differences, would be soil. Because sugar is one substance, and so are those, 3 and 4. When a mixture of water, sand, and salt is filtered, what passes through the filter paper? Anything that is big is going to stay in the filter paper. So water will definitely go through. Will the sand go through? No, it won't. It's too big. Will water and salt go through? Yes, because the salt is dissolved in the water. And we've already said that the sand will not. So choice 3. Solubility of KCl solid in water increases as, okay, so first of all, pressure is only going to affect gases. So you can't choose that. So then let's go to the reference table. And you see KClO3. And here's my line. It is increasing in solubility as temperature goes up. So increases as temperature of the solution increases. According to your reference tables, which of these compounds is least soluble in water? So that's code for saying insoluble. So let's go ahead and take a look at table F. Table F. So going back to table F. All right. We have K2CO3. Oh, so these are the one. Can I write over here? No. We've got K2CO3. We've got KC2H3O2. We've got Ca3PO4 taken twice. And we've got CaNO3. Okay. So I always look for the anion, which is the second part. So our first is carbonate. Carbonate is here. Carbonate is insoluble except when combined with group 1. So is potassium group 1? Yes, which makes it soluble, which is not what we want. I said erase. There we go. Our next is acetate. Acetate is soluble, no exceptions, which means that's not what we want. Then we have phosphate. Phosphate is insoluble except with group 1. Is calcium in group 1? No, it's not, which makes it insoluble. Finally, nitrate is soluble, no exceptions. So that's not what we want. I wanted this. Hello. So our answer would be the calcium phosphate. Calcium phosphate. According to reference table G, how many grams of potassium nitrate would be needed to saturate 200 grams of water at 70 degrees Celsius? Okay, so back to table G. Whoops. All right. And let's erase all this. Okay. So 70 degrees KNO3. So all the way up here. That's like 135 grams. But be careful, it says in 100 grams of water. So if it wants 200 grams of water, we need to multiply it by 2. So 135 times 2. Look, let's do some old-fashioned multiplication. And I can't do multiplication. This is bad. This is 270. Okay, well, anyways, please forgive me. It is late, as you can see. Late for me. So going back here, 270 is what I got. This is close enough, 268. Which of the following is most soluble at 60 degrees? Which means we need to go back and let's clean this up. Most soluble means it can hold the most at 60. So 60 degrees is here. So the first choice was NaCl. NaCl can hold 38 grams, just about. KCl, that can hold 46, I don't know. KClO3 can hold 29. NH4Cl can hold 58. So it looks like NH4Cl for the win. Because it's high, it can hold the most grams of solute. Come back. What the heck? Okay. A saturated solution of sodium nitrate is prepared at 60 degrees Celsius using 100 grams of water. As this is cooled to 10 degrees, the sodium nitrate will settle out, and then it becomes saturated. How many grams will be settled out of the original solution? So we need to go to table G, NaNO3. Clean this up. NaNO3 at 60. NaNO3 way up there. Looks like 126. But then it is cooled down to 10. And NaNO3 is this one. So it looks like 80. So 46 grams. And notice it's how I subtracted those, because it could hold 126 and then it cooled down and it can only hold 80. So the resulting number left over is how much precipitates out. Solution is formed by dissolving 45 grams of NH4Cl in 100 grams of water at 70 degrees. Describe the solution. Well, first of all, NH4Cl is the salt. It is the solute. So then we need to figure out, is it saturated or unsaturated? So back to table G we go. All right. It says NH4Cl at 70. So, and it's 40 grams. So it's right here. And NH4Cl, the line is here, but my point is there. So since my point is below the curve, that means it's unsaturated. Choice 2. According to table G, which solution is saturated at 30 degrees? Hold on one second. All right, let's see. So now let's go back to table G. Erase all of this. Okay, so 12 grams KClO3 in 100 grams of water. So KClO3 is this curve here. 12 grams is like here. Oh, and it's at 30 degrees. Sorry. 30 degrees. It looks like 12. Yeah, that looks good. Yeah, that's it. I'm not going to waste any more time. Since that's right on the line, that's the answer. You could go ahead and check, but it's right on the line. So, choice 1. Whoops. Choice 1. Based on reference table G, which salt solution could contain 42 grams of solute per 100 grams of water at 40? So let's go back again. All right, so 42 grams and 40 degrees. So 40 degrees, 42 is like right here, give or take. Okay, so it says a saturated solution of KClO3. So saturated would be on the line, and it would be here. So it's not choice 1. A saturated solution of KCl. Well, KCl will be right there. An unsaturated solution of NaCl. So NaCl's line is right here. The line is above that. An unsaturated solution of NH4Cl. So since this dot is below NH4Cl, that's our choice. Choice 4. Choice 4. Under which conditions of temperature and pressure is a gas most soluble in water? So think about a can of soda. If you want soda to be bubbly, you want it to be at low temperature, keep it in the fridge, and keep it under high pressure. These are opposite conditions of the ideal gas. When PbI2 solid is added to Na2CO3 aqueous, a white precipitate is formed. According to table F, what is it? Well, this is tricky because the first thing you need to do is do the double replacement, because I don't know what my products are. So if you don't remember, double replacement is when you switch your positives and your negatives. So instead of being with iodine, lead is going to be with carbonate. And you'd crisscross and you'd see that Pb is +2, CO3 is a -2, so you're good. And then Na is going to be with I. So now let's go to reference table F, like it told us. Okay. Erase. NaI. So first of all, iodine is a halide, which is soluble except with those. Well, none of those are sodium. And carbonate is insoluble except with group 1, which lead is not. So the lead 2 carbonate actually, is our precipitate. Whoops. And by the way, you could get rid of, well, they don't even have PbI. Well, you can get rid of this, and you can get rid of that because none of that exists. All right, meaning exists in the reaction. A solute is added to water, and a portion of solute remains undissolved. When equilibrium is reached between the dissolved and the undissolved, that is called saturated. It's called solution equilibrium, when you're saturated. No more can be added, and then no more can be removed. Okay, now we have some math. So where do you find all your formulas? Table T. It says, what is the total number of moles of NaCl solid needed to make 3 liters of a 2 molar NaCl solution? So back to the reference tables we go. Table T is right here. So we're looking at the concentration, molarity. So molarity equals moles of solute over liters of solution. So back here, it says molarity, 2, put it over 1, cross multiply, is equal to moles of solute over liters of solution. Well, you just cross multiply. So 2 times 3 is 6. Which phrase describes the molarity of a solution? We just saw this. Moles of solute per liters of solution. Number 18. What is the molarity of a solution if 2 liters contains 4 moles? Molarity equals 4 moles over 2 liters. So 4 divided by 2 is 2. Now, dilution formula. That's not on the reference table, but it's M1V1 equals M2V2. How many milliliters of our 12 molar HCl solution must be diluted with water to make exactly 500 milliliters of a 3 molar HCl solution. So our greater molarity is our M1, and this is our lesser molarity, M2. And we want to know how much of this, and we have 500 over here. So going to my calculator, 3 times 500 is 1500 equals 12x. So let's divide both sides by 12, and you get 125, which is a choice 2. Number 20, a 20 milliliter sample of 0.60 molar HCl is diluted with water to a volume of 40 milliliters. What's the new one? Okay, so 20 milliliters times 0.6 equals 40 milliliters times x. Well, I can do the math, of course, as I did before, but if I notice that my volume doubles, my molarity will be halved. So it's going to be choice 3. What is the molarity of a solution that contains 20 grams of calcium bromide in 0.5 liters of solution? So let me erase this. So this is a little bit trickier because molarity is moles of solute over liters of solution, and I don't have moles. I have grams. So before I go to moles, to get to moles, I'll need to divide by the gram formula mass, GFM. So calcium bromide, and I need to go to periodic table for that. Calcium, and you'll have to crane your neck. So 40 plus, and then bromine is 80. But there are 2 of them, so 160. So 40 plus 160, that's 200. So the GFM is 200. And so we're going to do 20 divided by 200. And that's going to give me 0.1 moles. So 0.1 moles divided by 0.5 liters equals 0.2 molar. A student wants to prepare a 1 liter solution of a specific molarity. You determine that the mass of the solute needs to be 30 grams. What is the procedure? So this is just what we did in the Kool-Aid lab. So the solute needs to go in first. So 30 grams would go in first. And if we want, I wanted a different color blue. That's a good blue. Add it. So then if I wanted to make 1 liter, I fill it with water to the 1 liter line. So now let's see which of those answers is what we want. Now I lost all the other colors. Okay, just do it. Okay. So it says add 30 grams of solute to a liter. No. Add 30 grams of solute to, no, solute goes in first. Add 1,000 grams of solute to 30 grams of solute, solvent to no. Add enough solvent to make a liter. That's right. That's what we did. What is the concentration of O2 in parts per million in a solution that contains 0.008 grams of that? Okay, so parts per million formula is back here. Parts per million is mass of solute over mass of solution times a million. So we're looking for parts per million. Mass of solute over the entire thing times a million. 0.008 divided by 1,000 times a million is 8 parts per million. There you go. How many grams of NaCl are needed to be dissolved to make 1 gram of a 100 parts per million solution? So now we know the answer. So we don't know mass of solute. We do know mass of solvent, or I'm sorry, total solution times a million equals 100. So this is 1 million x over 1 equals 100 over 1, because, you know, this is part of their equation, and then I'm doing that for cross multiply, except for we don't actually need to cross multiply, because then let's just say they're both over 1, so whatever. And so we'll divide both sides by, it says a million. So 100 divided by a million is 0.0001. 0.0001. So that's 1, 2, 3, 4. 1 times 10 to the minus 4. Choice 1. If 0.025 grams of lead 2 nitrate is dissolved in 100 grams of water, what is the concentration in parts per million? So 0.025 over 100. Technically, we should add that solute in because it's just water times a million. So 0.025 divided by 100 times 1 is 249.9, which rounds to 250 parts per million. Now again, the reason why I think I forgot this in an earlier question, is that you have to add solute plus solvent to get the total solution. Which aqueous solution of Ki freezes at the lowest temperature? So remember, you need the most concentrated. So the most moles in the least amount of water. Compared to the freezing point of 1 molar KCl at standard pressure, the freezing point of 1 molar calcium chloride. So now the molarity is the same. So now you need also more ions. So KCl breaks up into K plus, and that's a plus sign, and Cl minus. So that's got 2 ions. This is going to break up into Ca plus 2 and 2 Cl minuses. So that's 3 ions. So the calcium chloride has more ions, which means the boiling point would be higher and the freezing point would be lower. Standard pressure, when you add a solute, you're going to have more extreme. Higher highs, lower lows. So higher freezing point? No. The solution will have a lower freezing point and a higher boiling point. Choice 3. Which unit can be used to express solution concentration? So that would be molarity, which is moles per liters. Which is a characteristic of a mixture? A mixture can consist of a single element. No, that's an element. A mixture can be separated by physical means. You got it. Let's just talk about the last two. A mixture must have a definite composition by weight. No, because salt water could be from the ocean, super salty, and it can also be very dilute. It can be what goes into your contact solution. Very, very dilute. And a mixture must be homogeneous? No, like rocks and Rocky Road ice cream. All right, if you have any questions, please reach out. Thank you.